Good morning, guys. I just finished grading your Moth Lab and the single or Sex in the Single Guppy Lab or whatever. I noticed some common occurrences throughout grading the Moth Lab, so I want to go over those with you. Um, Keep in mind that a moth isn't just going to change its color to be like the tree. Okay, so they just don't change their color automatically. Now, I'm noticing when I'm reading this, let me see if I can go back. Um, well, here you can see I guess not in this one, it was on the last one. Um, it talked about the larvae that were changing its color to match the twig. Okay, those can do that. That's fine. Okay. That does happen. It's camouflage. Okay. However, what was happening with the moths is that we were finding that there was a black moth and then there was a lighter colored moth. And it wasn't because that light colored moth was deciding to change its color that day. It was a genetic variation or what happened to turn out to be a mutation. So a white moth and a white moth got together and produced offspring, and there was a mutation at some point in the replication of that DNA that caused it to turn into a dark colored moth. Okay, so now we have this one single moth that is black, for instance, okay, and then it's going to be able to reproduce and then it can pass its mutation on. Okay, so it wasn't that just all of a sudden these moths were deciding to change their color to dark. It was a mutation, and then that mutation eventually got passed on. So I want to show you. Okay, so the mutation explained why the moths were dark, but not why they were taking over. Okay, natural selection is what's going to cause that. I'm trying to see. Let's see if we can do I want to do the actual simulation with you. Even though you've done it, we're going to do the light one first. Okay, so when I'm sitting here looking, the first ones I automatically see are these black moths, okay? So a bird is going to see them first. Yes, we can barely see those lighter colored moths, okay, but, uh-oh, my bird won't move. There we go. Okay, we can see those lighter ones, but the bird might see a light one here or there as it's moving in front of him. Okay, he's trying to get it. Okay, those black ones are much easier to spot. Okay, so the light ones that we're seeing, I'm not going to eat them. I'm just showing you. These light guys, they're able to survive longer, therefore they are able to reproduce. Okay, these black moths, they can't reproduce because they're not surviving long enough to actually reproduce. Okay, so there was that one. Now let's go back and do the other one. Okay, now we've had this mutation. We have some of these dark colored moths that have survived, and now we have this polluted forest because of the Industrial Revolution. Okay, so the trees are dark. So now the bird sees all these light colored ones first, and he's going to eat them all. Okay, where are the dark moths? Well, they're blending in. Okay, what does that mean? They're surviving. Therefore, they have a longer chance to reproduce. So if they can live longer, okay, the longer they live, the more reproduction happens. Therefore, the more offspring that are going to have that dark color trait, okay, increasing the amount. Now, I've killed all these white ones, so therefore we're not going to have any lighter colored moths that are reproducing. So now that number is going to drop drastically. The dark colored moths are going to rise drastically, and now that's why we see that crazy quick change from like 0.05% to like almost 98%, okay? Because all of a sudden, all these black moths are blending in, and therefore they're going to survive, and then they are going to be able to reproduce successfully, whereas the white moths are not going to be able to survive and reproduce and be successful. Okay, so that is how natural selection works. I have another um, picture I want to try to find to show you because I feel like it is a good one. I should have looked it up before I started this. Thought it was natural selection with. Oh yeah, here we go. So here, let's just look at this picture real quick, if it'll pull it up. Okay, so there's mice living in a desert, okay? What we're going to do is we're going to start here, okay? We've got white mice. We're even numbers. We've got 4 white mice and we've got 4 gray mice, okay? This is all about what makes them more successful, what makes them more likely to survive and reproduce, okay? In this case, it's going to be blending in. So the gray mice should be better off, whereas that hawk is not going to be able to get it. So this hawk is going to come in. What is it more likely to pick up? Is it more likely to pick up a white mouse or a gray mouse? Well, it's more likely to pick up whichever one it sees first. And in this case of this picture, it's going to be more likely to pick up a white mouse because it's going to be easier for it to see it. Okay, so therefore, it's going to start picking off all these white mice. These gray mice are going to be okay. And now we have more gray mice as part of the population. Therefore, the gray trait is going to become more pronounced. Okay? Or there's going to be more reproduction that happens between gray mice. Therefore, we're going to have more gray offspring. Therefore, there will end up being more gray mice in the long run. And the white one will slowly dwindle. Okay? I hope that that makes sense. I wanted to clear that up because I feel like some people were thinking that the moths were actually changing their own color. Okay? You know, same thing for me. If I had to worry about a predator and being camouflaged, for example, was my only way of surviving from that predator, and I had to camouflage into this wall behind me over here, it's light pink, I can't just change my color to be light pink, correct? Correct. So there would have to be some kind of mutation that would occur that would cause me to become pink, allowing me to blend in with my background and not be caught by the predator. If that mutation happened and I was now pink and I could pass that mutation on, then that would make it more advantageous for me to survive and reproduce, therefore allowing me to pass on that trait. Okay, mutation or not. So that's when we talk about mutations can be beneficial. Okay, they're not always harmful. Mutations are not always harmful, so do not think that. In this case of the peppered moths, they became extremely beneficial to the moth population because had they not had the mutation, then the moth population would not have survived. Therefore, it would have gone extinct, and now that would have been not, it would have been extremely detrimental to the population. So this mutation in terms of the peppered moths was extremely beneficial. So mutations can be beneficial as well as harmful. Okay. If you have any more questions regarding this peppered moth lab, please let me know. Okay. You need to know that it was from a mutation and then that those moths that had the mutation eventually survived longer and therefore were able to reproduce and pass on that mutation to their offspring. And that's what allowed that dark peppered moth to become so prominent. Okay, so I just wanted to clear those things up for you guys. Hope you're having a good week, and I'll talk to you soon.